indicate if you had either a computer or a pencil and paper, or pen and paper. You have a pen, you have computer, you have computer. What do you want?
Yeah, I want that one.
You're gonna see as well?
Thank you.
Oh, you're okay. You're right. Yeah.
Who are our friends online?
Is there a way we can change that?
No. From Megan, Soraya, and Vanessa.
Oh, hi guys. Okay, well, I'm going to start, and please jump up and get more food anytime you want it. Don't be hungry, it's delicious. And thank you for coming today, and also thank you to the people online that have joined. And please also jump in whenever you have a question. Don't wait, just put your hand up. Well, I know it sounds very schoolish, but you don't have to put your hand up, but if yes, we do that, or just interrupt me. So today we're talking about directed acyclic graphs, which is a very common tool used in epidemiology now, but it can definitely be applied to other questions that aren't just epidemiological. How do I go forward? And not down arrow and not that arrow.
Yeah, sometimes this happens. Oh. Just unshare already.
And then do it again.
I am.
You got it.
Oh, now you get one.
Okay, let's just do that.
You need to reshare.
Alrighty, good.
Back to the Zoom thing. Share screen. Okay.
Any opportunity.
Is that right?
And you've got your arrows down.
Okay, we'll use these arrows. Okay, got it. Okay, so people that are in the room have been given either have brought their own paper and pen or have a pen. And if you're at home or somewhere else, you might want to have one too, or you can do it on your computer. So where we're going today with this particular lunchtime seminar is when and why we should use DAGs, and we're going to learn a little bit how to create one. And we're going to hopefully, if you have a computer, you can actually do it yourself with the DAGs tool. Otherwise, you'll just do it with pen and paper. And then we're going to finally come to what is the minimum adjustment set. That is, what is our minimum set of confounders that we need to adjust for? Because that's ultimately what DAGs are for. So these resources, we will go through, I'll put them up again at the end, so don't feel like you have to write them down right now. But the first one that's awesome is dagity.net. If you've ever used it, then have a look at it. I mean, if you haven't used it, have a look at it. It's really, really helpful, and you don't even need to know how to what a DAG is to use it. It's so good. And then the next resource there is, you can read it there, it's about Daggle. This is actually an app that was created by someone at UNSW, and I helped on, which is basically a teaching tool and a tutorial about what DAGs are, what they mean. Gives lots of examples, and then it's really cool because it gives you little scenarios, and you have to choose which things you think are the confounders, what you should adjust for, so it tests your knowledge. So it was developed for teaching, but it also, you can use it to teach yourself. And then the last one, I just wanted to put a plug in for this paper, which these are by no means all the authors. There's many authors on this paper this paper was written by all these authors from editors on all the respiratory, sleep and critical care journals. But it basically talks about causal inference as a whole part on DAGs and just a lot of stuff that's going forward with epi in the respiratory space. So it's kind of a really nice go-to, easy to read paper on how we should be using epidemiology in respiratory health. So first of all, actually before we ask the question, DAGs, what are they? Who in this room has actually used a DAG before? Why?
I think I did a gene relationships,
Okay,
sort of,
okay.
but I wasn't sure.
Who's thought about using them before? Okay, couple. Who's just here because it's lunchtime and, you know, it's free lunch and I've heard about this.
I have.
We do lunch, come on.
We did one for the bushfires for the erasmus paper. I didn't do it, I just watched it happen.
Okay. So.
I do them all the time.
Say that again.
I do them all the time if it makes you happy.
You did what? What
I do them all the time.
Oh, good. All right, so it's a really.
I'm Daggy.
Yeah, I know, that's my favorite thing too. We use them to help visualize confounding and mediation structures, right? Which I think in all research questions you pretty much have to consider confounding. So that's why I think this applies to everyone. But the words, or the letters, the acronym DAG stands for directed. That means going in one direction. So it consists of arrows, as you can see in my sample picture there, arrows going in a single direction. The acyclic means that your outcome, in this case, perinatal outcomes, does not come back to your exposure, so it doesn't cycle around. And graphs is just, it's a picture. Yeah, it's visual. So why should we use them? We use them because when we are thinking about our question of interest, we want to have evidence-driven decisions on our confounding structures rather than statistics-driven reasons. So I would say like when I am asked to review papers, the most common thing that I do when I review is I ask the person, have you used a DAG? Because invariably what they have done is they've got their confounders, or what they think are their confounders, and they've measured, done some statistical testing to say, is it 0.05 or less different, different from sorry, that didn't come out right. Is the association with the outcome significant or not when they just look at all the potential covariates? And if it falls under 0.05, they say, yes, okay, it must be a confounder, let's put it in our model, right? And if it's not, they ignore. And this was the traditional way of doing it for such a long time. In fact, when I started my PhD in 2009, that was how I did it too. But what has happened over time with the leading epidemiologists is they've said, well, we shouldn't be just relying on statistics and mathematical reasons to do this. We should actually have evidence-driven reasons for the confounders that we're choosing, as in evidence from the literature, not just what is happening or what we just happen to have information on for our study. So we may even ultimately consider things we haven't measured. And we should be doing that because we should be thinking of every possible thing that could be confounding our associations, and it should be driven by what we know in the literature and our experience. So ultimately, it will do two things. It will reduce over-adjusting, because that's another thing I commonly see. People just put like the whole kitchen sink in, and you're like, why are you even doing this? You just had this stuff, so you put it in. But this method as well helps you to think about what is actually important. And plus it reduces any potential unforeseen bias that can happen when you just put the Kinderson sink in. Or even if you did that statistical testing method and you've only come up with 3 and you're like, I'm gonna put those 3 in, but they could even be interacting together in a way that causes bias of the ultimate association, and because you haven't visualized it and thought about it and seen what's going on, you don't know that that bias is going on. So your result is actually unknowingly to you biased. And also it's about transparency. It's about being able to say, this is how we thought about confounding. So in that way, a lot of people do actually publish their DAGs, but not always. And I have done a mixture. Usually it might be something we chuck in the appendix. Sometimes we don't even, but it means we should at least keep a copy. So if someone comes back to us and goes, why on earth did you make that decision? We're like, here you go. So that's how it works. Are there any questions on this? Because, you know, I don't know all the research you do, but maybe you do the statistical method. And as I said, it's still happening a lot, but if I see an epidemiological paper in particular, I usually will be like, go back to the drawing board. So just.
Bronwyn, I've got a question. So sometimes you hear people talk about how a confounder has to be related to both the exposure and the outcome, not just the outcome. Is that related to what you're saying about the statistical method? Or it's only considering its association with the outcome?
Yeah, that's exactly right. And that comes down to how do we define a confounder, which is we're going to do in our next slide. So very good question. So, actually no, it's the slide after this. When do we use them? So first of all, you should be using them when you have a question of causation. That means you have an exposure and you have an outcome. So they're not so useful for cross-sectional type work, okay? Because it kind of relates to what you're saying, that confounder has to relate to both exposure and outcome. It usually needs to be temporal in nature, i.e. one happened before the exposure happened before the outcome. So is that something that you do in your research? Is it a before and after thing? So there needs to be an exposure and outcome. So it's not so useful for RCTs because then you can just use your basic high-square UG test because you've dealt with all your confounding by the structure of the RCT. And you use it, and then it's not that useful in cross-sectional studies. Although you can use it, I have, but it's not great. So it's useful when you want to visualize your relationships between a set of variables and you want to consider the confounding and the mediation or the moderating factors. So I'm gonna do a practice question, but I want you to come up with one as well. And I just made this up. Again, this is not a real question. So because it's not a real question, really, it comes with a few issues. But I thought it would be good if we had a fun one, right? So does eating chocolate in pregnancy increase the risk of asthma in children? We're all okay with asthma, we all like chocolate, but let's just go with this as our practice question. But I want you to think about for your own work, and hence the piece of paper, I want you to think about what a causal question could be in the work that you do. What is your exposure and what is your outcome? And if you're on a computer, you can do it a different way, which is go to dagity.net and then you just launch the paper on your computer. Is anybody doing it through their computer, even the people online, so I know who to kind of wait for to show these? Okay, so we go, and also you, rest of you can have a look better. Yeah, so everyone just take a minute or two to put your question in.
Do registries, send you.
Okay, who said something?
I was just going to say something.
Oh,
So
like
I-
you're up there.
so I often don't use daggedy but draw.
Yeah, me too.
Oh, okay. So that's okay.
This is kind of like a check.
Yeah.
So I'm gonna draw it on here so that if you guys want to use it, and I do encourage you to use it. So I'm going to, and I want you to draw yours similarly. So this is what it's gonna look like. I'm gonna put chocolate here. And then I'm gonna put, so this is my exposure, now I'm putting child asthma over here as my outcome. All right, now, Vanessa, do you know what to do? Just click on the screen and do that. And then I hover over chocolate and click E, and that creates my exposure. I hover over the asthma and I click an O, and it makes the outcome. And then I'm going to draw a line between them, because that's my causal pathway that I'm interested in testing. So I'd like everyone to draw something like that, with your exposure and your outcome. And take lots of room, because you are going, you know, we've got to create a big web. So you need room. This is very, I do feel very school teacher. As everyone, is everyone talking?
Yes, we're working together.
That's okay. Okay. So now I have to be smart. Right, so we do that. All right, now what we're going to do is, here's my example again. We're going to add variables. I don't want you to add any lines. I don't want you to think about what they are. I just want you to add variables now. And I want maximum 3, because the thing about DAGs is they can become really chaotic and look like cobwebs. And that is okay to a point, but right now for our teaching purposes, just choose 3, please. Content. It's good to use that skill again.
Teaching skill, style.
Student. I feel like, yes.
We need this.
Student.
Students dedication.
Capacity.
Dedication. Students learning capacity.
All right, so remember 3 possible covariates, and as you can see with my one, I chose stress. With stress from my chocolate, and because I have done heaps of research to show that women who are stressed in pregnancy have an increased risk of asthma, which are mainly kids. And I always put socioeconomic status in. I mean, unless you're doing something non-human or you're doing genetics or whatever it is, as soon as you're doing anything with epidemiology or with populations, you should, it's like an automatic, it should be there. And then I'm also going to look at child BMI. And now we're going to think about, this actually comes to your question now, Vanessa, sorry, it took a while to think about how do we think about these variables? How do we know if they're confounders? Maybe they're just random stuff. Like one thing you might have thought that I haven't put in, which I could, is sex, because we know that boys have more asthma than girls, right? So I could put that, I should put that in. So what we're going to do is just talk about how do we decide which arrows, so that directed part, do we put in? And this is where we have to think about whether what we're looking at is a confounder, or is it maybe perhaps a mediator, or is it doing nothing? So the confounder it has to be something that is associated with both the exposure and the outcome. If it is only like child sex, only associated with the outcome, then it's not actually a confounder. So, because I don't think that a woman would eat chocolate or not in pregnancy because whether she had a boy or girl fetus, right? So it is not a confounder. It has to be something that affects both.
Can you still put it on the DAG?
Yeah, absolutely. So I can show you, we might put the sex one on, because the thing with sex, especially with asthma, is we tend to adjust for it anyway, even though it pretty much never is a compounder. But that's not a kick that a review is having.
Yeah.
So
Okay.
we think about that. So is it associated with both? And another really important thing is it cannot be on a causal pathway. So here's another thing that as a reviewer, I'm often saying to people, and maybe you do too, commonly, because I do a lot of reviewing of perinatal papers, and commonly they're looking at some exposure in pregnancy, let's say less stress, and then they're looking at some outcome that happened afterward, let's say asthma, and they want to adjust for birth weight because they think birth weight affects asthma, which it definitely does. If the baby's small, then we have an increased risk of asthma. But what is the association between the stress of pregnancy and birth weight? Right? Do you, first of all, think there is one? Would a woman who is stressed maybe have a smaller or bigger baby? Maybe smaller? Right? So we think, yeah, there's an association. But in which direction does that association go? Does the stress cause I mean, I sort of said it already, but does the stress cause the preterm birth, or does the preterm birth cause the stress? It's pretty obvious, it goes in that direction, right? So because everything is going in this direction, I should do it for you guys. So we're going stress to preterm birth to asthma. That is a causal pathway going in one direction. So technically that birth weight is on the causal pathway, so we should not adjust for it as a confounder. We might want to deal with it in a different way, which we will talk about. That is, it is actually a mediator. It's on the mediation pathway, but it is not a confounder. This is like common thing that I am telling people. Why are you doing this? Do not do this. It is on the causal pathway. So just something to think about. And then another way to think about confounders is sometimes it's not really obvious what the association is with the exposure group, but you may know from, I don't know, some other research that whatever it is you're looking at is unequally distributed in the exposure group. That would imply that there's some kind of relationship, but sometimes it's not super obvious. Like it might be postcode A and postcode B, and you're looking at smoking, and you're looking at an example right now. There could be some extraneous reason, I think is what I'm trying to say, about why you have different covariates happening in those exposure groups. It's just something to think about. But generally, my thoughts are always rule 1 and 2 there. And also the last thing is it could be measured or unmeasured. And as I said before, it's good to consider unmeasured, because even if you can't do much about it, you may find once you've done the DAG, it doesn't matter, which is awesome. Or 2, it matters, but you can write it in your limitations. We know we wouldn't do X, right? And we want to do it later. Okay, so now we're going to add the causal pathway. So I want to take you back to my example and show you first, and then I want, first, and then I want you to have got yours. So I have here childhood my. Okay, so I said before that I know that if we're stressed, it's pretty well known that we like eating chocolate, so we're gonna put that one in there, right? Agreed, arrow? And I know, as I said, from my own research and many other people's research, that women who are quite stressed in pregnancy have an increased risk of childhood asthma. So I put that arrow in there, and automatically in Daggerty it goes pink. And that is in Daggerty, which means it's a confounder. And so what we're seeing here is that if something is, there's a confounder if it has an arrow going that way to the exposure and that way to the outcome. So it's pointing to both. If it can affect both, that is our rule 1 from the slide before. All right, but watch what I do for the next one. Chocolate and child BMI, it's a bit like the birth weight example I gave you. The relationship between chocolate and BMI is going to go in this direction, right? Because if, let's say, she had excess of chocolate, maybe the child will have a large BMI. And we know that a BMI is related to asthma. In this one, this is a causal pathway. So I still put the arrows in, right? We put the arrows in for every single variable, but now this is showing me in Daggerty it comes up blue, which is a very nice way of it telling you this is a mediator and this is not something that you will adjust for in your association. Okay, and then I'll just do my last one. So socioeconomic status. Now we know that's related to asthma, so I'll put that in there. But we also know that if a woman perhaps has poverty, she may be stressed. But do we think that socioeconomic status has anything to do with chocolate? So we can, one thing I probably haven't said is that we can join these variables to as many things as I really want to, right? So I'm going to say no, because chocolate is very affordable. So I'm just going to go, you can get the cheapest chocolate, you can get expensive chocolate, whatever. I'm going to say we can all eat chocolate. So I'm not going to put an arrow in there. I'm just going to leave SES over here. Do I think SES is related to child BMI? Probably. So I might put an arrow there. Okay? So that is how I am currently going to draw my graph. And as you can see with SES, again, the arrows are pointing away, so it's coming up here. That pink is looking like a confounder. So with your 3, see if you can have a go at working out what you think your pathways are and in what direction.
And so it's a confounder because it's targeting the exposure via stress.
Exactly. Exactly. There is a pathway going. I like to kind of think of it like water. Like this is, so that if this is tap here on stress and it's wetting that and it's wetting that. And same here, there's water coming out here and it's going through here and it's wetting that. But with this one, the water is actually going all the way through the chocolate to the child asthma, right? Mm-hmm. Yes. It's not always the most perfect analogy, but it sometimes helps.
I think you don't like to for them not.
So all these arrows we need to draw based on evidence.
Exactly.
Yeah. Thanks for that.
And then again, if it only points to either the exposure or the outcome and it's not on a causal pathway, that's like a totally different.
So if I had another one, you mean like if I had let's say, I don't know, all of it. Another one I thought of was country of birth, let's say. Is that what you mean?
Yeah. And like that will only point to asthma. It doesn't have anything actually to do with.
Okay, so like if I took my sex of the chart example, which I didn't do, this one, it only points to here.
Yeah.
Yeah. Because I don't think that any of those things, child BMI, I don't even know, I'd have to look that up, but
To say it doesn't.
yeah, so I just put it in like that. And again, I mean, I'm giving you a simplified example, but I would definitely try to put in everything I think is important. But there's a question of limitations on how much is important, as in, sometimes with some people I work with, I'm like, can you just cut all these ones out? Because they're so peripheral, like, yeah, they could have effect on this, on this, on this, on this. There's got to be a point when you stop, so I think you have to think of the main. often good to get someone else to look at it too, who knows the area and might think of stuff you've forgotten. But I also could have, yeah, another one over here. And then I'm like, and it's its own little confounder over here that could happen as well, right? But then I may leave that to socioeconomic status if I was really.
Yeah.
So I'm just gonna take it out for a minute.
Yes.
Because we just, I don't wanna overcomplicate it.
I also have, you know, commonly I'm using like physiological variables that you can either use the absolute variable or you can already adjust that to a percent predicted for a given sex age.
Yeah,
So then you wouldn't include sex again.
exactly, because you've already taken care of it. I mean, you could, because then you would be doing that to justify why you were using the standardized one, or whatever it is, with the safety notes, to show this is why I used it, because it's obviously important for this.
Yeah, okay, that makes sense.
Yeah, okay, we all good? Okay, so, let's get back to the PowerPoint. So, I've simplified mine now, didn't have the socioeconomic status to child BMI step, but I should. And in your example, can you work out which ones are your confounders? Because obviously your page doesn't go pink and blue. So can you work out and maybe just put a C or an N on the ones that you think are confounders and the ones that you think are mediators?
So mediators have to be connected to both exposure and outcome, don't they?
Yeah.
And the ones that float around that aren't connected to both, are they something else, or they're maybe things that are irrelevant?
Well, it depends. Like socioeconomic status in this example is not directly connected
Sure.
to both, but again, it's that if you think of it like water, what's going on? Like,
Yeah, but in that example that you had as a daggity before, where you had something only coming off
Yeah.
sex. Yeah, sex.
yeah.
Is that a mediated? The web?
No. Oh, yeah, it did, but no, it's not.
It's just a
That's
random.
a very, yeah, okay.
So
That's
I've got some green, grey and blue that are just hanging around.
Okay, well, grey implies then it's not measured. Why do you have grey?
Because it's gone from the exposure to the covariant. So I thought exactly.
Oh, yeah, no, that's fine. So that really is saying you really don't, yeah, you don't need to worry about this, or this.
Okay.
These are the, and not even that. These are the only two you need to
Okay.
think about.
So why does it go blue?
Why does it go blue for the child sex?
Yeah, when it's not a mediator, it's.
Yeah.
It's a random strings.
Yeah, I know.
Anything off the outcomes not blue, anything off the exposure maybe, but yeah,
Yeah.
it doesn't have both.
Yeah.
Measured is not relevant.
No,
Yeah.
that's exactly right, it's because it's pointing to the outcome, yeah, okay. Let's see. So, if you're in DAGs, and I'll go back and show you this in a moment. The top right-hand corner actually gives you now the answer for what you need to control for. And what this is called, so I'm just going to go through this and then I'll go back to DAGs and then we'll talk about yours, is we are identifying the minimum adjustment set. So not every single confounder, the minimum adjustment set for the total effect. And the total effect is, as I've written here, the effect of the exposure on the outcome through any pathway, through any mediating pathway, through anywhere. Like now, from a public health point of view, that's probably the most relevant question, because if I'm looking at whether I want to put an intervention to tell women that they shouldn't be eating chocolate, I want to know, is chocolate going to affect that child's asthma? And I don't really care what pathway it takes to causing asthma, whether it's through the BMI or whether it's through some completely other thing, like which preschool they went to or something. Because the fact is, I'm saying what's important is this exposure, right? And this is another thing that people often, you know, this is the thing that I bring up when they're reviewing, like if they're adjusting for the birth weight or the things in the pathway, I go, are you actually interested in whether chocolate in pregnancy is related to child asthma through no other method than the fact that it must somehow be directly related in utero? Is that what you want to know? Is that publicly health, whatever word is relevant to us? So, or do we want to know the big picture? And usually, more often than not, I think people actually have asked in that name and want to know this one, the total effect, and they don't realize that they haven't actually done it. So I just show you, because you can see here, it says at the bottom, stress. But in our picture, we found two confounders, remember? So why is that only saying stress? This is the minimum adjustment set. So what it's saying is we only actually need to adjust for one thing. We might have measured socioeconomic status and we might think it's a great idea, but actually through our DAG, we only need to adjust for stress.
Is that because we don't care if SES has a relationship with stress, because it's still on a pathway between? That was me.
Yes, partly, you're right. So this is when I think the water analogy sort of works again. Think of there being a tap at stress. Think of when you adjust for stress that you are turning off the tap. So when I turn off that tap, those pictures, the water now can't get through from socioeconomic status. Yeah. Right? So it can also turn off the child BMI one, but we have that problem that I said that you're just kind of over adjusting. So again, this is telling me I only need to do the one thing, and it's a legitimate thing to do, but I might get a reviewer who goes, we always adjust for socioeconomic stress. Why have you not done this? And then you go, here's my dad. Yeah. Does that make sense? Now, if you can, think about it in your own. If you worked out your confounders, think about, would you for yours need to adjust for all of them? Yeah. Yeah, can we make that? Should jump to the floor. Okay, so see, this is where I got it from. Just this part here, this is where you get it from in W. You just look up there, and it's so good. And then, so if Vanessa McDonald, you do it, do this guy again. If you do it on paper, it's good to test it by this, so you get to the conclusion that you already.
Yeah.
And even when I put that arrow in, it's still okay, because this is 22 million, so we're already happy with this water being turned same line, because we're interested in the whole effect, right?
Yeah, you don't, it's still going that same direction, you don't care how it gets there.
Exactly, you don't care how it gets there. Radio. And you can see this one didn't come up either, because it's not a compounder. Did I go over the top?
No, you're amazing, bro.
Okay, thank you. You're welcome. And yeah, I can send out the patterns. Now, if let's say I did want to know if child BMI plays a part. I'm interested in this because, again, from a public health point of view, we could go, you know what, it's way too hard to tell women to not eat chocolate, but maybe we could impact child BMI. So we choose that this is our impact. But we want to know, if I impact here, is it going to actually make a difference? Because maybe this pathway is like really small compared to this physiological pathway in utero, right? So there could be reasons that you want to actually investigate mediation, and I have done tons of mediation analyses because I am interested in this pathway. So it's not an illegitimate pathway, it's just what is your question, right? So let's say we want to look at that for a second. If we do that, we are looking at what is called the direct effect, because we're basically saying, if we adjust for this, what's this effect? And then sort of jumping ahead a bit here, but let's say, it's probably easier to use an example. Let's say the total effect that we worked out once we put all our data in and put it with, adjusted for stress. Let's say the odds ratio was 2, right? We know that if the woman eats lots of chocolate, there's a risk of 2 that the child will have, right? Then what we do is we want to understand what effect this is happening. We adjust for this as well. And then we measure, so all we're doing is adjusting for this, so the result that we get from our modeling is just this association, and let's say it comes back 1.5, right? So this is saying if it's 1.5, that means that the child BMI must be taking up that 0.5, the difference between the 2 and the 1.5. Does that make sense? Right, and so it was 2 on total effect, and then it's just 1.5 on the direct, we call it the direct effect. So it's saying, so we can happily say from that, oh, obviously chocolate has a direct effect somehow on this increase of child asthma, but also a part of it is definitely going through child BMI. Does that make sense? Okay, so when in DAGs, we can do this. We can go to here, and it will tell us what we happily need to adjust for if we want to look at the direct effect. Okay, so it's telling me I have to adjust for this, I have to adjust for this, and then because of this error here, I have to also adjust for this. Okay, if I took that arrow out as I've done in my example, SES disappears, but this is part of what we do. Does that make sense? Okay, now we come to one other really important part of DAGs, and then we're kind of done, because this is probably one of the parts that I think tricks people the most. So I've done that, that's the direct effect. Is this. When you start doing things with mediation, and maybe you already have this in your diagram because it doesn't just happen in mediation, but it's a common place for it to happen. We're looking for this, 2 arrowheads pointing to a covariate. Does anyone have that in their diagrams? 2 arrows pointing to a covariate. So here I don't, it's pointing, but it's going down. But here I have 2 arrows. So this is called collider bias because it's a collision, right? And if you think of the water example again, the water comes this way, it meets, and we can think of it as being stopped, right? The water meets, it stops because they stop each other because they can't go back down. So when I was looking at the total effect, I'm looking at this, and I'm happy for the effect to go through here. Because of this collider bias, water meeting, then pretty much this is having no effect. I don't need to worry about it, right? Because it's like, it's kind of the opposite of turning that off. It doesn't need to even be turned off because it's already stopped. So this is not having effect. I don't need to adjust for it if I'm looking at the total effect. All right.
And if you do adjust for it, that's bad, right?
If you do adjust for it, so it's kind of like a tap on in reverse. You've now turned it off and you've said that
It was off and you're turning it back on.
Yeah, perfect. It was off because it was just naturally happening off, and now I've turned it back on and I'm creating pathways through here. So this is now actually having an effect back onto that because I've turned that tap by adjusting for it. So before I adjusted for it, life was happy, then I adjusted for it, and all of a sudden this becomes a confounder. Short version is, if you're doing mediation, consider these confounders. They only occur between the mediator and the outcome. It doesn't actually have an effect on this side. It's just something to think about, because again, it's another thing that I see people doing this and they forget about this, and so their whole mediation analysis becomes confounded. So it is a bit, as I said, it is one of the harder concepts because you've got to kind of get this double arrow thing. But the thing is, it can happen even in, not just in this mediation example, it can happen up here as well. Like the minute I have something here pointing down to stress, then there's a double arrow, and I have to think about what's being stopped and what's going, and it can do your head in a little bit, and that's when DAGs can be helpful. So like, for example, there's a thing called M bias, where if you have a variable here pointing down to chocolate and stress, you get this M thing happening. And if you decided to adjust for that, it opens the whole M. But if you didn't, everything would be blocked and you'd be it becomes confusing, and you have to then adjust for everything in your model. Okay, so hopefully that somewhat makes sense. I know you might be a bit lost. I would say use DAGs, use me, and use the double, if it's something you're thinking about, use the double tutorial that we created, because I might help with that too. And then the last thing I just wanted to talk on, we'll just go through that for a minute. Oh, so this is what we ended up with the workshop. Like this is what our total effect is, what we would adjust for, and if we were doing a direct effect, what we would adjust for. Okay, so the last question on here I want to talk about for a second is, what do I do if I have unmeasured confounders? So here's an example in DAGs where this now, if you click over it, you can press U, you can make it unmeasured, and it's, as I said before, it's really important to put those in if you know them. So let's say I hadn't actually measured maternal BMI because I'd forgotten to do that when I had my pregnant women. And I went, oh, okay, what am I going to do? But then I realized through my DAGs that it doesn't affect my total effect. That's what we said before. This can still do this, and because of collider bias, this is blocked anyway, so it's happy days for total effect. But direct effect, I would not be able to work it out because once I adjust for this, it opens this pathway, and I don't have this. So I either don't work out the direct effect, or I do it and I say to my readers, by the way, it could be confounded by maternal BMI, which I forgot to measure, right? And one thing I have to put in mind quite often is, because I'm often looking at maternal asthma sorry, again, it's a similar example. Actually, I can put it could be in this example. Not very well though. One thing I have to think about is genes as an unmeasured confoundant, because usually we haven't measured them in an epidemiological study. But if we think that genes, of course, are related to the child's asthma, of course they are, and then they're related to the mother, and it could be explaining part of what's going on here because the child simply inherits genes from the mom, then we put that in often as unmeasured, and we have to decide how much it's affecting. Just something to think about if you're working in that space. And so we've already kind of talked about how do you choose them, and I said just choose the main ones, don't make it too convoluted, and do where you report it, it's up to you, but it is quite nice to put it in your appendix if you can, and then we talked about that. So that's pretty much it. We are done. We have 7 minutes if you want more food or if you want to ask any questions. Oh, I do have one more slide, sorry. Because you might have seen the email, but there's the resources again, which I'll put up in a sec. Is just to kind of segue into, I am now 1 day a week as an e-biostats consult for the group. So if you need help with these things, come and ask.
What day is that?
Any day, I'm just gonna manage it.
Okay, that's dangerous.
Oh, if it gets to over day, I'll just tell you. Like, I mean, my preference is to train you or help you rather than me do it for you. But if it works.
So Vanessa, Peter, and I have done a DAG, and it feels, maybe because I just haven't thought about it now after seeing it, but it feels a lot more complicated than that. So maybe I'll put it in DAG.
Yeah.
And then make it work with you.
Yeah. Yeah, I love that.
It probably is more complex than chocolate and pregnancy.
Yeah,
Yeah, I think the other
Breathlessness in airway disease.
yeah, and you guys are the subject experts, but I can certainly cover that. But yeah, give it a go first.
Yeah.
Yeah, so is there any other questions?
It is mainly used in cohort studies, or can we use it in RCTs?
No, you don't need to use it in
RCTs.
RCTs, because in RCTs you shouldn't have any confounding, so you shouldn't have to deal with this stuff. The fact is that you created the RCT to get rid of its balanced.
But we used to have a confounders in the adjusted in the regression modeling.
But then the question is, why do you have?
Yeah, why we do?
I mean, you'd have to be really justifying a good reason to put them in. I've seen that before too, and I always find it a bit weird, but if they have looked at the two groups and there's an obvious difference that the randomization didn't get rid of, well, then you could probably think about it, but you'd have to have a good reason. This shouldn't be, yeah.
And because the study that I was talking about was cross-sectional, so obviously that's not, I think that's also the nature of the question, like it would be impossible almost to have, you'd have to have like a live cohort.
You could, I mean, as I said, I have sometimes done it, like when we looked at asthma and comorbidities in children, or we were looking at asthma and depression and anxiety in children that was comorbid, but there were things we looked at, like socioeconomic status. It's still the thing you should adjust for. And that one we did sex of child, but it becomes a little bit harder to draw the DAGs.
Yeah.
I sort of had it with an arrow going in both directions. I mean, that sometimes can be tricky.
I think that's,
But it's not impossible, even if it just helps with the thinking, but you just have to be really aware that you can't know which direction that thing's going. Is there anything else?
I feel like Vanessa's drawing on the screen.
Oh.
Vanessa or Olivia, I couldn't work out who's drawing.
And you guys, I didn't know you could see that.
Yeah.
Yeah.
A little pen.
Sorry.
And when with Jaggedy, you can save the code or something, can't you? How do you do
Yeah,
that?
I'll show you more. So
Come back.
that's a good question, especially Haley, if you're going to use it, is yes, because you can't, I mean, I often just will screenshot the picture.
Yeah.
But invariably I want to go back and change it because I've changed my mind about something. So you go into the model code here
Okay.
and you have to copy. Hey, sorry, I am doing teacher on you. Do you do that?
yeah.
Just make sure you copy and then paste your code into a Word document, and then you can just put it back in and it'll create the same model for you, because there's no other way to keep your models.
Yeah.
And then, although the other thing is you can export them in all different forms, and there is archive and all this jazz. I don't do any of that stuff, but it's there if you're like high tech and do that. Yes.
Question. What happens when something or things are affecting each other, so the arrows could go in both directions?
Yeah, that is such a good question, and it's really hard. And I think it is actually the main limitation with directed acyclic graphs. And I had that situation recently, and I just really couldn't decide. Like mostly, the epidemiologists are like, decide, make a decision, and I'm like, but it's so not clear. We know in the research this particular relationship is bidirectional.
Yeah.
So I can't remember what I did in the end. I probably modeled it both ways and then had a really big think about it and went, okay, well, if it's going to look this way, what does it look like? If it's going to look that way, what does it look like? Is it changing a lot that I have to adjust for? You could even then potentially offer two models in your analysis, in your, in your results table. This one may look like this one may look like that. And then you interpret it from there. Depends how important it is. If it isn't that important, I make a decision. But if it is, I would strongly consider looking at separately. Yeah. Anything else? No? Good. Okay. Well, thanks for coming. If you want if the slides are at all useful, let me know and I'll see you guys. Thank you. Thank you. Welcome. Oh, right.
Oh,